So I've got it set where it's recording now. So this is the last module that we're going to be doing in the class. And this module, basically, as you sit there and see in the PowerPoint, it talks about dictionaries and sets. We're not responsible for covering sets, but I'll go through and talk about what dictionaries. Dictionaries are basically a more, like, we've been kind of working in our data structures we're working with. And last time we met, we talked about working with lists that were basically indexed, an indexed group of values that you had, where you had a group of values all together in a data structure that was indexed by a number index. So the difference between lists and dictionaries is dictionaries have basically items in it, but they have key value pairs. So you could have a key like name and a value like Tim. You can have a key like age and a value like 51, things like that, where you can go through and you can have a collection of data that has key value pairs that match up together. And that's kind of the main difference. And this kind of gets us into a little bit more advanced structures. So we'll switch over to here. And I'm looking to make sure on participant list there, so that way I don't miss anybody showing up. So the topics, obviously, we're just going to talk about dictionaries, and then we're also going to be talking about the concept of serializing an object. So what is a dictionary? A dictionary is an object that stores a collection of data, and each of the elements in this collection are going to consist of a key and a value. So basically, you're going to have, like I said, you're going to have a key that gives you access to the value as opposed to an index. And then you're going to have the value that's associated with it. One of the things that with your dictionaries is we talked about the concept of mutable versus immutable objects. So once you create your dictionary, your keys will become immutable. However, your values are mutable. So you can change, like once you can set the keys, once you set the keys, they're set, but you can change the values associated with those keys. So when we sit there and we look, the format for creating a dictionary is dictionary equals key, colon value, comma, key, colon value. And all of this is in curly braces. One of the things when we worked with lists last time, lists are in square brackets. And then, dictionaries are stored with curly braces. That's kind of one of the other main differences in how we define them. So when we store values in a dictionary, they're going to be unsorted. And the general format for when you retrieve a value from the dictionary is whatever your dictionary name is, and then in square braces, the key for the value you want to retrieve. So if I have a dictionary with a key of name, it would be dictionary, and then here would be name, and that would return me the value that is associated with name. One of the things is if the key that I try to use to access a value in the dictionary doesn't exist, if that doesn't exist in the dictionary, it's going to throw a key error, or it's going to throw a key. You're going to generate a key exception. One of the ways to avoid that is you can test to see whether a key is in the dictionary or not by using the in or not in operators. And this, again, helps prevent key error exceptions, especially if you're not doing any kind of advanced error handling. So when we want to add an element to the dictionaries, like I said, dictionaries are mutable objects. However, the keys are immutable. So when I create, basically the first time I do it, if I have dictionary key, if I want to change the value, I can change the value, but this key will never be able to be changed. You have to keep the key the same. And one of the things is if I go through and the first time I do this, if I say dictionary key equals value, if this is the first time accessing it, it kind of creates the key value pair. But if that key already exists, then the value associated with that key is going to be changed. So it allows you to store different values with your keys. You don't have to keep, once you create your key value pair, the key can't be changed, but the values associated with that key can. If we need to delete a key value pair from a dictionary, the syntax is just simply del, or for delete. the dictionary, the name of your dictionary, and the key. And again, you probably want to check to see if the key is in your dictionary before you try to delete it, because if you try to delete and it's not there, you will get a key exception. We had one more, isn't it? So we'll wait a second. Here we go. And okay, looks like we're on. So just kind of going through to kind of recap, since we're going, the topic this week is talking about dictionaries. And then we'll also cover a little bit of serializing objects. Sets is something that we don't cover in the class. A dictionary is very similar where we it's basically a data object or a data, basically a way to store data in Python that allows us to sit there and store data where we can have our values in this data object. We can be associated with a key as opposed to when we had list where we have an index. One of the things, and we were talking about just going through talking about accessing elements within when we're working with a dictionary. If we need to add items to it, the way to add an item is to say dictionary at key equals value. And when we want to go through, if for some reason we use the same syntax, if the key already exists, instead of adding a new value associated with that key, it's going to change the current value associated with it. If we needed to delete an element from an existing dictionary, the delete is done at the existing key value pairs. So we're going to, the command is just simply del dictionary key, always in square braces. And anytime that we try to access a key within a dictionary, if that key does not exist, Python is going to raise a key error exception. So dictionaries like our list also have the ability to sit there and do some additional functions with it. We can use the length function to obtain the number of elements in a dictionary. So if a dictionary has 5 elements, if we use the len function, that will tell us how many in it. Again, one of the key things when we talk about dictionaries, your keys must be immutable objects, but the associated values can be any type of objects. So we can theoretically have a list at a key. We could have another dictionary at a key. We can obviously have string, integer, floats as well. And when we sit there and we look, one dictionary is allowed to include keys of several different immutable types. So if we can have a key that is string, we can have a key that's number, we can have a key that's float. You kind of get the ideas. And a lot of times when you're working with a dictionary, the values can be of different types. So like, for example, if you had a dictionary that you called student, you would have the student name that may be string. You may have student ID, which may be a number, or that could also be a string as well. And student grade, which would be obviously probably a float or possibly an integer. You can have multiple types within the same dictionary. So to go through to create an empty dictionary and then go through and loop through, there's several different ways. There are 2 ways to create an empty dictionary. The first would be to sit there and use just open curly brace, close curly brace. That creates an empty dictionary, or we can use the built-in function dict, open paren, close paren, to create an empty dictionary. Either way, we can add once we have that empty dictionary, we can go through then start adding key value pairs to the dictionary from there. And then if we need to iterate over all the values within a dictionary, the general format is a for loop, and it's for key in dictionary. And then basically this is going to go through and give us each key, like what is stored in each key. And I'm trying to avoid saying the value of each key because we're, And then we would access the dictionary at that key to get the value associated with it. So if for some reason we have a dictionary and we need to delete all the elements in it, we need to clear it all. We don't want to call delete one by one. We want to just, we don't know how many items are on it. We want to just clear it. There's a clear method that's available. And if we go through and we look and we say, we also have a get method, and a get method will gets a value associated with a specific key from the dictionary. So if I call dictionary.get and I say key, and then at comma, I put a default value, basically using this format of getting a value at a certain key from the dictionary will not raise a key error exception, because we're specifying that if the key is not found, return this default value, if that makes sense. And then obviously the other way to get a value at the dictionary is dictionary and then the square brackets operator. And the difference between this and this is this, if I have a default values with the default value I have set here, it will not return a key error exception. Another method that's associated with dictionaries is the items method. So basically with the items method, we can go through, and it's a different way to iterate through the dictionary. We showed that went too far. So we showed here that we can use a for loop where we can say for key in dictionary to loop through. With using the items, we can also use a for loop, but basically what it's going to do is that for loop, and instead of going through and giving us each key and then having to use that key to get the value, what this is going to do is iterate over all the tuple, like all the tuples in our loop, in our thing, and it's going to give us the key and the value with each item. So it's obviously a little bit different. There's also a method called keys. The keys method returns all the dictionary keys as a simple sequence. And then basically what will allow us to do is that gives us just a list of what the keys that are in the dictionary, that so you can sit there and see what's stored in there. It doesn't store any of the values, but it just shows you the keys. The pop method will return a value associated with the specific key, but the difference between the get method and the pop method is when I say dictionary.pop, whatever value, like whatever, once I call that pop method, that key and that value are going to be removed from our dictionary. Whereas get will return the value, and if the key is not found, it will return whatever we say is the default. Pop will also return the value or the default, but if the key is found, then it's going to remove that key value pair from the dictionary after we pop the value from it. The pop item method returns a key value pair, and it returns a specific key value pair from it. So as you notice, there's no parameters we pass into pop item, and that's because pop item goes and looks and it returns the last item added to our dictionary. So if I call pop item, it's going to give me the key and the value of whatever the last thing that was added to the dictionary was. And just like the keys method, we also have a values method that gives us all the values within our dictionary. But note that when we get all the values, if we loop through and we get all the values, we will not have the associated keys with it. So you may not have all the information you need. And again, you can use a for loop to iterate through that. And then here's just kind of a quick summary of all the different methods that are available. Like I said, there's a clear method that allows you to clear all the contents of a dictionary, essentially giving you an empty dictionary. Get allows you to get the value associated with a specific key. And if that key is not found, return a default value. This is an easier way to get the value from a dictionary and avoid throwing a key error exception. The items method is going to return all the keys in a dictionary and their associated values as a sequence of tuples. So this allows you to loop through each each item in the dictionary and giving you the key value pairs. The keys returns all the keys that in a sequence of tuples that you can loop through and use to do different things with. Pop again does the same thing as get, just the difference is pop, once you get the value, it also takes that key value pair out of your dictionary. Pop item does the same thing as pop, except it returns the very last item added, and then values returns a sequence of all your values that are in your dictionary. So just like with our lists and stuff, we also have the ability to do comprehensions, these special expressions that read a sequence of elements or add a sequence of elements into our dictionary. So for example, if we want to create a dictionary where the keys are integers 1 through 4 and the values are the squares of those keys, and kind of pay attention to this little bit of hit because this may be in some of your assignments that are out in one of your assignments out there. If I go through and I create a sequence of, a list of numbers, 1, 2, 3, 4, and I say squares is an empty dictionary, and I say for item in numbers, do a loop for item in numbers, squares with the key of squares, the dictionary squares with the key of item is equal to item squared. That's going to return this dictionary here. It's going to return 1, 1, 2, 4, 3, 9, 4, 16. So as you sit there and you look, there's several lines of code, but like with the comprehensions, we can also sit there and define a dictionary squares. Again, we know it's a dictionary because of the curly braces, and we say item, which is the key, colon item squared for item in numbers. So again, we still have declared this list of numbers, but now instead of doing our loop this way, we have our comprehension that does the same thing. And this kind of explains the comprehension again, where it's showing this is the result expression. So this is our key value pair that we're adding. And this is the iteration that gives us those key value pairs. For example, if we had a list of an existing list of strings that were names for here, we can sit there and if we wanted to create a dictionary that basically took the string and then associated the value with it was its length. We do the same thing, within curly braces, we say item, because we're using names. We say, and we're using for item and name. So this kind of defines what item is. And this time, instead of, doing the square of it, we're saying item and then the length of item. So in this case, we have a dictionary that has Jeremy 6, Kate 4, Peg 3. So if we need to make a copy of a dictionary, one of the ways that we can make a copy of the dictionary is if we create dictionary 1, again, we're in curly braces, and this is just by defining it, where we have key of A, colon 1, and a value of 1, key of B, colon value of 2, key of C, colon value of 3. We can, within our curly braces, use a comprehension where we say K and V, key value for K, V, and dictionary items. So as you see, this is how we use that items method in the for loop, where you have for a variable for the key, a variable for the value, and it takes those and builds a new dictionary. So when we sit there and we look, here's what the definition of dictionary 1 was. We ran this code, and then here's what the value of what the definition of dictionary 2 is afterwards. So just like with our list in our comprehensions, we can also use the if clause. So as we sit there and we look, we say population, we have a dictionary of populations, which has a list of cities and their overall population. And we're looking to create a dictionary that shows the largest cities, and largest cities are defined that have a value of higher than 2 million. So as you see, we go through, we have our 4 KV in items, and we're only doing it where V is greater than 2 million. So when we go through and we run this code, the values that are in largest are New York, Los Angeles, Chicago, and Houston, because out of our original list, those are the 4 that have values higher than 2 million. So we're going to skip over the set stuff because it's not covered, and I should have deleted it out. And as you see, there's a lot of things. So the last topic of within this module is serializing objects. And basically what serializing objects allows you to do is, when you serialize, like if I have a dictionary, I can go through and I can serialize that object to make it a stream of bytes that I can write to a file. And within Python, there's a concept called pickling, which is basically serializing that object. What this allows us to do is we can create a dictionary, or we can create a dictionary of dictionaries, and have that basically take that and take the values that we take all the elements that we have in our dictionary and write that out to a file. And unlike where we were writing it out, where it writes out the text of the file, this will serialize it and basically store it in a file where when we read it back in, we get, instead of having to do something to the string we're reading back in, we can read it back in as a dictionary as well. So in Python, there is a pickle module to do this. And basically we're going to pickle an object, you open the file for binary writing. And then there's a dump function that you call pickle.dump, and you pass it what the object is. So this would be our dictionary. And then we write the file. Now we can also, objects are not limited to the pickle command. It's not limited to dictionaries. So like last week when we wrote list out, it wrote the list out as a string to our file. If we say pickle.dump and we write out the object to the file, we write out our list to our file, it's going to store it in a binary format as opposed to storing it as text. And then basically you close the file. One of the things, if I have multiple objects with my thing, I can take multiple objects and write them to the file, and then be able to go through and iterate and pull them back in, pull those multiple objects in for use. Then of course, if I pickle to write to the file, basically I unpickle to retrieve from the file. So I would essentially go through and import the pickle module, open the file for, I would assume, for reading, because if we open for writing, it's going to clear it. We call the load function. We call the pickle.load function on the file, and then basically we close the file. And what that will do is that will give us the objects that are, in the file. And again, this is kind of a quicker thing because it's going through, but I am going to work a lot with examples for this, because it's kind of, I think working with examples sometimes for this stuff is a little bit easier than looking through the PowerPoint. But basically, dictionaries are very similar to lists. Instead of a list where we have values that are stored in a list and we use an index to retrieve the values, we have a specific key that we can use to retrieve values within our dictionary. That makes it a little bit easier, because we don't have to worry about, like within a list, we have to worry about, okay, am I, look for, okay, I know my list has name, age, and phone number. I have to loop through and guess what index name is. I have to guess what index phone number is. I have to look and guess what index, I have to go through and make sure that I store things in the right order to be able to sit there, that I'm going through getting the right indexes in my list to be able to make sure that I'm getting the right values. With a dictionary, I have a key of name. And I know I'm going to get that value. I have a key of age. I'm going to get that value. I have a key of phone number. I know I'm going to get that value. Dictionaries make it a lot easier that when I'm looking to store multiple things of data in one item, it makes it a lot more easier to store that. And that's the end. Oh, sorry, I stopped sharing and I didn't mean to. That's what I meant to close. So obviously in this chapter, we have in this section for the class, we have all of our normal things here. We have some more dictionary examples, and we'll open those kind of to use for reference on things. But within the module, we have an additional Zoom file that kind of shows some of the things. We've got a file that shows our key points. We've got from the author of the book, our video notes from that. And then one of the things too is, like I said, this is kind of an example that sits there and shows that our dictionary values aren't limited to strings and integers and things like that. We can also have a dictionary value that's a list. We could have a dictionary value that's a dictionary, and then the PowerPoint that we went through. So real quick, before I go into the assignments, obviously we have our standard quiz this week, and next week we have our preparation assignment. The preparation assignment it's one program, but it has two different parts to it. So pay attention as you're going through working on it. And then we have our regular assignment, which is also one program that is going through doing different things with working with the dictionaries. So with that, file. So we're going to go through, and like always, we're going to work. So one of the things that we can go through and kind of just showing we're going to define our main, working to show dictionaries. And I'm not going to worry about trying to use this main as a function and doing the test for it and all. So I start by defining main. So I'm going to create the first dictionary I'm going to create is student, and I'm going to create it as an empty dictionary. So now that I have this, if I just save this, save it, I run it. When I go through and I run it, because I've defined student as an empty dictionary and I just print student, I don't do anything fancy with it. You see here that I get the empty dictionary, and that just kind of shows you that we have an empty dictionary in student. So one way I can add values into student is, say for a student, I am going to store the name. I'm going to store name. And for name, we'll just comma that. Now that means I'm having another item, and we're going to say class. And grade. And I'm not spelling right tonight. I need to study what I teach better. So if you look right now, I've now defined my dictionary student. So as you see, I have a key of name with the value of Tim, a key of class with the value of COP 1000, and a key of grade with a value of 85. So if I save and run this, now it just kind of, you see, that's what I have in my dictionary. So I'm going to clear that out. So now if I go through and I want to loop through my dictionary, one of the ways to do it is to say for K, comma, V in So now I'm going through and I'm going to make it a little bit clearer. This is information from the student. I save this and I run it. Now you see as I went through and I looped through it. And I'm actually going to put, just to make it easier when we see the input. So when we look, this is what's on our dictionary. And obviously I'm printing, this is the information from the student. And you notice it says name has the value Tim, class has the value COP 1000, grade has the value of 85. So after demonstrating that, I decided Tim has a better grade. So I'll just, for the heck of it. We'll print that again. Save, we run. So now we sit there and we look and we see, we started off, here's what our dictionary was. Because I went through and by doing this, because grade exists, instead of adding a second grade, what it does is it changes the value of grade from 85 to 90. And I just realized I want that to be an integer because it also changed the type. And again, we see here. And if I do student, and it doesn't have to be capital letters, I have a habit of doing, we can add Boolean. Should I notice when I did color? So now when we sit there and we look, we go through our dictionary here. This is our initial dictionary. I looped through it the first time. I got the value, got name has value of Tim, class has the value of COP 1000, grade has the value of 85. Loop through, I changed. So then I changed the value of grade and I added a key value pair of passing. So now where we sit there and we look, I have name has the value Tim, class has the value of COP 1000, grade has the value of 90, passing has the value of true. I can also, if I wanted to, instead of saying true, passing has the value of, because this is a Boolean expression, I can also use a Boolean expression. So I was able to access the student grade and see if it was greater than 60. And if student grade is greater than 60, assign that to passing. So obviously this is just some simple ways of working with our dictionaries. So I'm going to save this one, going to do another new file. So one of the things we can do with dictionaries, like I said, we can use our dictionary types for our values. We can have a dictionary that has types of dictionary. So we can have a dictionary with dictionaries. So again, this time I'm going to create a dictionary. I'm going to call it class. And class equals, and like I said, I can, if I'm going to create an empty dictionary, and notice again, Python kind of gives me some help. I can go through and do different ways. So I can use the, different things to be able to go through and populate my dictionary, or I can just say, and do it that way. And that creates an empty dictionary called class. And class is going to be, so I'm going to say class class at name. Oops. And I'm going to create a dictionary here, students. So one of the things, if I just left that there, and then say, this will give me a dictionary that has a dictionary within it as a value. However, this should also throw an error. Once I save it. Why is it saying invalid syntax on that? Okay, obviously I have something that's a. Why does it not like my equal sign?
Is it because class is like a keyword?
Oh, yeah. Thank you. I keep forgetting that. Certain languages you can use keywords as variable names and it doesn't matter. Certain words, certain languages you can't. Hey, we got past it. So notice, okay, so when you sit there and you look, notice how I created students, and because I only use the key of student one, if I had different names, and I save this, you're going to sit there and see students only has the last one, because even though I'm creating a dictionary and I've got multiple items listed there, because I'm using the same key, whatever the last item with that key is what gets stored in there. So if I needed to, now if I save it again, save it and run it again, now you sit there and you'll see the difference between that. Because with this with the first definition where I left it all as student one, it only gives you whatever I assign the last value with it. But since I have a different key for each item, I have my dictionary. So here's the main dictionary, which has the name, COP 1000, students, and then the value of students is a dictionary in itself. That kind of makes sense. You know, it's kind of, when we sat there like last week when we were talking about lists, we talked about two different dimensional lists. This allows us to kind of sit there and do different things with it. So, kind of to take a quick pause, and do you guys have any questions, anything kind of that I'm going too fast on, any? And I've got the chat open as well if you needed to. So kind of going through, I saved off the examples. Of course, my computer's going to be slow. So close off that demo. So let's go through and look through some of the other examples that they have in the book from the assignment. So let's see what this does. This is using a special function called CHR, which basically, if you take a character and if you take a number, aka the ASCII value of a character, and pass that number into the character function, it's going to return the value of that, like it's going to return the character associated with that ASCII value, as we talked about. So first thing it does is it creates a empty dictionary of ASCII. And in that and then it uses this loop for n in range 65 to 123, which are 8 ASCII values. And it goes through to sit there and say, hey, go through and basically at each character, show me the ASCII value, and then we'll dump it. So we'll just kind of run this real quick to see. So when we run the first part, and I'm going to maximize it to kind of make it look standard. As you see, our dictionary ends up being populated with capital A is 65, capital B is 66. So remember how we talked about how Python does comparison of string comparison. It does an ASCII comparison. So you would think that if you had it would make sense thinking in regular logic that an uppercase character would be greater than a lowercase character, but actually it's not in ASCII values. So greater, uppercase A is lower than, a lower value than lowercase a. But this kind of gives you an idea of what all the ASCII character and value pairs are. And then if I type in my name, it goes through and it converts, basically gives me the output of the ASCII values of my name. Looking at our code, we go through, and again, we use a range to populate our dictionary. And then from here, basically what we're doing is we're saying, okay, if we know that we have a list of, we have my name, I can go through and loop through my name through each character of my name, doing a for each. This gives me each character in name. And then basically it goes through, and because I created my dictionary of the ASCII, of the ASCII values with the key of the character, I can very easily do a simple print of that ASCII character, of that value, the value at each character. So that's one way to do, to work with a dictionary. So another simple program that does it is when you sit there and you look, we see we've got branches. And what do we have? We have the branches, the 3 branches of the United States government, which is the executive, legislative, and judicial. Well, the executive branch is the president, the legislative is the Congress and the Senate, or the Congress, which falls both, House of Representatives in the Senate, which is the Congress, and then judicial branch is the Supreme Court. So by doing the 4K in branches, that when we do the loop this way, the value we're getting out of branches is each of the keys. So basically what we'll print out is it'll print out the blank, the executive branch is, and then it gives us the value of branches at K. And then if we were to use the items method, we go through and this is the KV, KV variables for the key and the value, and items, because items returns a key and a value, and then we just print it out that way. And running this program. So again, when we sit there and we look, this program is going to return the ASCII Unicode characters based off things. So we're going to start, it starts at the, and this is using the comprehension to populate our dictionary. So when we sit here, we look, it just prints out starting what it's doing, and it says range 97 to 102 is the ASCII lowercase values. So when we look, we see that the characters dictionary is going to be the character CH, which is the ASCII value this time, and the character associated with it. And again, all lowercase. And this is going to give us a list of pals. And basically when we go through, the second part of this goes through and we create a list of pals, which is a list of names. And we're going to create a simple dictionary that uses name, loops, again, using the comprehension for name and pals. It uses name, key value of name, and then the length, and it prints out that. So kind of looking at that again, when we look start of lowercase alphabet, when we sit there and we look 97, 98, 99, 100, 101. So that gives us A, B, C, D, E. And then the second part, the second list we built, Penny's name contains 5 characters, Al's name, it's using the using the different elements of it. So then another way to go through and work with the dictionaries is we've got a dictionary called grades, and grades has test 1, test 2, test 3, test 4 with their values. So if we print it, you'll just sit there and you see if I create a variable KS that's keys, this gives me just the keys of it. This just gives me the values of it. And then if I have where I go through and I look for a test, it's going to sit there and look and say, if the test is in grades, get me the grade. If not, say that test doesn't exist. And then the last part shows using the pop method where it pops a test. And it's going to show that which one was removed and show you what's in the grades. And then it's also going to sit there and show you what the clear method does. So if you look, this is just the printing. This is this line right here, the printing the grades. It shows what's in grades. We went through and it showed out what's in the keys. So we have dictionary keys, which is test 1, test 2, test 3, test 4. Dictionary values 90, 80, 84, 88. So if I type, so it shows that the value, the grade of test 1 was 90, which it was. Then it did a pop of test 2. So it shows that the grade of 80 was removed. Notice it didn't show test 2 was removed. It shows what the value was removed. So the pop function returns the value associated with the key, but it also removes it. And now when I sit there and I look at the list after the pop function, notice the 80 for test 2 is there. Now it's not there. And then when I call clear, there's nothing in my dictionary. Looking at the learning stuff. Obviously, talking about pickling, it just talked about pickling values, but we don't have anything in our assignments about with that. So looking at the preparation assignment. So the first part is create a dictionary with states and their state abbreviations in their capital cities. And then do a while loop. Basically do all. First part goes through adds four states with capitals. And output the following, and then inside a while loop, you give the user the ability to add states to the dictionary. And if the state they try to add already exists, it's going to tell you that state exists already, and to enter a new one. And then it'll go through using the items method, loop through and show what each of the states are, show that how many states you have in your list. And then the second part is to use a comprehension to create the dictionary, and then and specifically create a dictionary with values that shows the odd integers and the cube of those values. The keys are the odd integers between 1 and 9, and the values are the cubes of those values. And instead of using the items, it uses a for loop to output the values. So as a bonus, we'll kind of work through the second part right now. So looking at the requirements for the second part, we're going to use a dictionary comprehension to create a dictionary with odd integers from 1 to 9 as the keys, and the cubes is their values. So we're going to have, so I colon I think so well. Remember, because it's an integer range, we want to have 10 because otherwise it'll stop at 10. And just for the heck of it, we'll start with that. So when I run it, notice I do have my dictionary, but I have evens as well. And that's because so that's a good start, but remember we can. So if I add in this little if clause that says only if I modulus division 2 equals 1, because we know that if we do modulus division by 2, if we get 1, that means it's odd. If we get 0, that means it's even. So now we've got our dictionary, and our dictionary has odd keys and the cubes of those odd keys. And you've got to trust me that the values are the cubes. So now to do the second part of the assignment on that, which is use a regular for loop without the items to print the values. So come back into our code, and instead of doing print, so for the syntax for our for loop, and use a for loop to display the keys. So it's going to be so when I do this for loop, when I do a regular for loop as opposed to looping through the items, all I get from this loop is the key. So I'm printing out what the key is. I'm printing out what the dictionary at that key, the value at that value of in the dictionary at that key is, and then other text there. And if we did that right, this was what was in the dictionary. 1 cubed is 1, 3 cubed is 27, 5 cubed is 125, 7 cubed is 343, and 9 cubed is 729. So as we're going through, obviously with the dictionaries, it's very similar to the list, but it gives you a little bit more ability to go and select specific items based off of knowing what the keys are for it. Do you guys have any other questions? Anything else you want to see with dictionaries? So kind of as a bonus, we'll go back over to here. I'm sure I'm taking advantage of all 500 of my 500 of my megabits of up and down tonight between doing a Zoom call and my kids streaming stuff out in the other room. So kind of going back to the number system. So I'm just going to kind of work through just using regular old Notepad or Notepad++ to go through and kind of do some conversions between numbers. So when you're working with the number systems and working with numbers, the three basic number systems that are used within programming and used within computers are your base 10, which is our normal number system that we work with, your binary or your base 2 numbers, which is kind of the root of what all computers do. That's when you hear the term bit, when you hear the term bytes, megabytes, and all that and everything, it's all related to binary. I mean, just, a bit is one binary digit, a megabyte is a million binary digits, things like that. And then when you go through, when you look at base 16 is based off the number 16. But with your base 16 numbers, your base 16 numbers are very related to your binary numbers, where if you sit there and you take a 4-digit binary number, that very easily translates to your base 16 number. So kind of working through first thing. So say we have 10110 as a binary number that we're going to convert. And let me there we go. Easiest way to get my font size bigger. So you sit there, I have a So if I sit there and I look, the easiest way to convert a binary number to base 16 is to sit there and we look, this has 5 digits to it. So since I know every 4 digits, every 4 of these will give me a base 16 number, what I want to do is come through and break this into 2 4-digit breakdowns. So this part is easy because it's going to be 0, 0. Going to be 0, 0, 0, 1. And then we're going to have 0, 1, 1, 0. So that basically, this, if I take away the space, is the same thing as this. Well, 0, 0, 0, 1 in binary is equal to 1 in base 16. 0, 1, 1, 0. So this is one, the one place. So that's 0. This is, so this will be 0, 1. If I have a 0 here, then it's 1. This is the 2s. This is the 4, and this is the 8. So if I add those up, I've got the 2 and the 4. That gives me 2 and 4. Give me 6. So 1, 6 in base 16 should equal, if I did all that calculating right, if I did all that right, 1, 6 in base 16 should equal to the same thing. And we'll go to programmer and switch into binary mode and say 1, 0, 1, 1, 0. So if we look, we see hex, which is the base 16, equals 16. So as you sit there and you see, you look up, as you go through and you convert, when you're going from binary to base 16, the easiest way is if you, however many you have, you want to break your digits up into 4 from, from right to left. And if you have, like in this case, we had just 1, you 0 pad it. And then you understand that this column is 1 and 0. So it's basically, we're doing this is not working good for doing what I want to do. This column is 1 times whatever it is. This is 2 times whatever the value is. 4 times the value, 8. And then whatever you get here, you add it up, you add them up. So in this case, it would be 0 plus 4 plus 2 plus 0 or 6. Obviously, this is just 1, so we get that, and that's where we get the 1, 6. So again, when we know what binary numbers, we have the binary numbers have letters within them. So going from base 16 numbers have, hexadecimal numbers have letters within them. So say we have the hexadecimal number AF. Again, we sit there and we can go through, if we're going to binary with this, we can very easily sit there and look and say, okay, if I look and I say, okay, here, what is A equivalent to? Well, A is equivalent to, in decimal, A is equivalent to 10. So to get 10, if I'm saying 8421, I would have 8 and 2. So A would be equivalent to 10 or 0, 8, 0, 2, or no, 8, 0, 2, 0, or 1, 0, 1, 0. The 8, 0, 2, 0 is the columns for the binary. And the A equals 10, and then I'm kind of move the F out there. F equals, in decimal, F equals 16. Well, 16 is 8, 4, 2, 1. Right? 15, I'm sorry, F equals 15. What was I thinking? 8, 4, 2, 1. Well, since that, if I have an 8, 4, 2, 1 to get 15, that's so AF in binary is 1, 0, 1, 0, 1, 1, 1, 1, 1. I'm AF in hex, so if I go type A F 1, 0, 1, 0, 1, 1, 1, 1, 1. So obviously you see that going from binary to hexadecimal and going from hexadecimal to binary, those are the easiest conversions to do. It's when we have to go from either of them to decimal that kind of makes it a little bit harder to do. So if we come through and so I have the number 0, 1, 0, 1, 1, and then we're going to convert that to decimal. So if you look over here, you see kind of how I started working through and building up. So we have different values for each of the columns. So I have 8, 4, 2, 1, and then I need 2 more columns. So that is 8, 4, 2, 1, 16. And I'm going to put spaces to make it easier to see this. 32. So now coming down here, I have 0, 1, 0, no, 0, 1, 1, 0, 1, 1. So kind of looking at my columns as I look through, this is the decimal number here. So I have a 1. So to convert to decimal, it would be 1 plus 2 plus, I don't have a 4. I have an 8. 8 plus 16 plus 32, 36, 37, 67. So equals 69. And if I did that right, I'll come over to calculator and okay, my columns are off. My column values are off because, oh, wait a minute. 1, 2, 4, 8. 16. It's not 32 then. Ten. Oh, I had my alignment off on it. There is no 32. That's why. So scratch that. basically the way I do it is you sit there and you look, you go 1, 2, 4, 8, 16, 32, and then the next number would be 64, 128 associated with each of the columns, but and then basically I multiply 32 times 0 is 0, 16 times 1 is 16, 8 times 1 is 8, 4 times 0 is 0, 2 times 1 is 2, 1 times 1 is 1. Add that all up, I get 27. But you can see how it can get confusing. And this is, in doing this, when you do the numbers quiz, this is kind of how I want to see the work. If I want to say, so if I went and I wanted to convert the hexadecimal number D3 to decimal. So sometimes the easiest way to go through and do from hex to decimal is to go to from hex to binary to decimal. So if I have D3, D is equal to A is 10, B is 11, C is 20, D is 13. So again, 1, 1, 2, 4, 1, 2, 4, 8. Going through looking, if I'm looking to get 13, 8 and 4 is 12. So D is 1101. 3 is 0011. So now that I've got that, I take this and kind of expand it and say 28, 60, 60, 64, 32, 16, 8, 4, 2, 1. I have 1. I have 1. I have 0. I have 116. I have 0, 8. I have 0, 4s. 1, 1. So then it's going to become 128 plus 64 plus 16 plus 2 plus 1, 130, 74, 130 and 130 and 84. 130 and 84. So it's going to be 2 something. $211 is what it'll end up being when you add all those numbers up. Was that kind of making it a little bit clearer or making it more confusing going through looking at doing the binary to hexadecimal?
It's definitely weird.
Yeah.
It's a bit confusing, but I understand it a little bit.
Yeah. Like hexadecimal, like the biggest thing to understand is for hexadecimal. So I'm going to close this one. When you're working with hexadecimal numbers, basically each character in your hexadecimal number is equal to the 4-digit binary number. So if you always remember 8, 4, 2, 1 for your binary columns. And then if you have, so as you go through and you look, whatever the decimal equivalent of your hexadecimal, like if you're sitting there and if you're looking, if you have 0 through 9, obviously it's easy to go through, but if you have an E is equal to 14. So out of 8, 4, 2, 1, how would I get 14? I would need an 8, a 4, and a 2. So the binary of E is 1, 1, 1, 0. So it's kind of, when you're going from hexadecimal to binary, it's kind of looking at each hex value, and that hex value is going to translate directly to each binary number. And kind of going back the other way, if I have a binary value, as long as I know the 8421, it's very easy to sit there and say, okay, 8421, 8 plus 4 plus 2 is 13, or 14, I'm sorry, 14 works out to be E. It's when you have to go to the decimal that it kind of gets a little bit, because now you have to know, and there isn't any, like the binary to decimal, there's nothing that's any bigger than, would be bigger than 256, which should be 8 bits. So if you kind of sit there and show 8-bit, it would be 8, 16, 32, 64, 128. So when you're looking in your binary columns, in the columns for the binary, so basically kind of looking, here's, you kind of see the delineation of the first 4 and then the second 4. So as you're going through from binary to decimal, each one of these columns in binary has, first column is either going to be 1 or 0. The second column, if you have something in the second column, it's going to be, it's going to be 2 or 0. If you have something in the third column, it's going to be 4 or 0. If you have something in the fourth column, it's going to be either 8 or 0, 16 or 0, 32 or 0, 64 or 0, 128 or 0. And then you add, like in this case, it would, to convert all ones to decimal, it would be 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which equals 255, which equals, and that's a hexadecimal setup that I know. That's the and it's those numbers are just something that when you become a web developer, you kind of learn that just because of color codes when you're talking RGB codes. And that's the only reason I know that, those conversions between each other. But the resources probably, I was going to say, okay, the number system, that YouTube video is still working. And then here's another video, and I don't have it playing the audio, so, and it kind of explains more in how I'm doing it. But there's a lot of things about working with number systems going between base 10, base 2, and base 16. So any other questions, any other comments, any other things that you might want to see help with? So if that's it, the 2 remaining things you have is your number systems test. So the biggest thing here is if you want to use calculator and just real quick do it like that, you'll get it, but you only get 50% for the grade. So the highest maximal grade you can get is a 50, which is still an F. but you can go through, you got to supply how you manually got to the process of getting the grade. And then the other thing other things that are due is for module 9. You have the preparation assignment and then the regular assignment. And there's only one program for each. And they're both working with dictionaries and doing the different things that we talked about. So any questions, any comments, So, and if you look, everything should be due December 7th at 11:59, which December 7th is next Wednesday. Is the quiz timed? I forget. It's got a 20-minute time limit, but we have your you're set up to where you have accommodation set on that, Cheryl. And the number system quiz is the numbers, even though it says test, the number systems test is only 5 questions. So, and obviously, as you sit there and see this, unlike all the other ones, I have to manually grade it. And that's mainly because of the show your work part of it. You can get the correct answers, but if you don't show your work, you're not going to get credit. Any other questions? So for the rest of this week, I'm going to have limited availability via email, but I will be back like full with full access to everything else starting on Monday. But like I said, I will have limited availability via email and stuff like with that for the rest of the week. But I will be available to try to answer questions as best as I can. And if not, we'll have next week to work through and get to whatever help we need. That sound good?
Yep.
Okay. So if you guys don't have any other questions, I'm gonna stop sharing my screen and I'm actually gonna end the class. It's been a great semester. You guys both, Vlada and Cheryl, you guys both have worked very hard and I don't expect anything major out of these I don't expect major failures in these last 2 assignments because I know you two have worked hard and done very well so far going in the class. I don't see any surprises for you guys. So just saw my teaching schedule for next. Oh no, you didn't. I'm not sharing screen. Never mind. So if you guys don't have any other questions or anything, then I'm going to end the call and I'm going to try to have the recording posted tonight. So if we don't have any other questions, have an awesome rest of the semester and hopefully you're doing as well on your other classes as you're doing here.
Thank you and have a good anniversary tomorrow.
Yeah.